Let's take a look at example 2. You are given a specific graph behavior. It's a function that behave differently at different times, and generally you see this uh, this function appears to have some linearity in it, except that it is not a continuous linear function like y is equal to mx. It is linear different times. For instance, this curve is linear from this point to this point. In a sense, I can see that this function f of x have different behavior. So it probably may be 2x from x is equal to -1 to something. It may be minus 2x from x is equal to 0 to something. It can be maybe 2 from this or negative. So as you can see, the functional behavior changes depending on the range at which the function is performing. The question that we have right now is we want to be able to determine the value of these individual functions at a different x value. So the function here, which is y, the behavior y is this function here. What is the value of uh, uh, the function when x equals -4? So let's come back here. So let's take a look at the question again. The complete graph of the function f is shown above, which of the following are equal to 1. Okay, so let's go back and take a look at f of -4. And this is a good way to really read a graphical representation of a function very well. So the first thing you want to do is you need to establish the scale. Now this is our origin. As you can see, this is our origin. So this is 1, this is 1. So every box represents 1 unit. So this -1, -2, -4. So f of -4 will be right here at this point. So f of -4 obviously. So f of -4, as you can see, will be equal to +1. So f of -4 in this case is 1. Let's move on to the f of 3.2. F of 3 over 2 will be equal to let's see, why is 3 over 2? 3 over 2 in essence is equal to, which will be somewhere right here, because this is f of 1, f of 2, f of 3 over 2 will be right here somewhere. Now that put it right here. There's a function. As you can see, the function is moving this way. You see that, right? So, and that is also, this is also equal to 1. How about f is equal to 3? Now f is equal to 3. Where is 3? So this is 0, this is 1, 2, 3 right here. So f of 3 is equal to somewhere, which is also equal to 1. And therefore we can see that f is equal to, so here we can see that f is equal to 1 is equal to f is 3 over 2, and that is also equal to f. I mean, this is -4, sorry, this is -4, and it's also equal to f is equal to 3. So all of them are the same. That means I, and I are all equal to 1. So the answer choice should be D. I hope you can use this to actually determine how the function behaves and how to read the function if you don't have a unique function like this. So here you can define the function as f of x moving from here to here, within the range of 0 to 0. F of x is equal to maybe -half x ranging from 0 to 1. F of x is equal to 1 ranging from 1 to 3, and f of x is equal to negative, say, half x ranging from, say, x equal to 3 to x equal to 4. That is how this function behaves.